Hi class, welcome to topic 3, DQ1. In this DQ, we are going to look ahead at our finance formulas. You're going to start seeing these in Alex. You'll see them in topic 3 and again in topic 4. These are also going to appear on the major assignment. So in this DQ, we are going to look at 3 different problems that use our finance formulas. Make sure you go through the finance formula document. I attached it to my post. I shared a link for the document. It goes through and explains each formula and gives examples for each formula. In the DQ template itself, I have a second tab that has the list of the formulas that Alex provides you with their Excel equivalent. Now, I don't have any labels provided here, so please make sure you get your own cheat sheet with your own labels so you know which formula is which. Okay, so on the DQ, always make sure you start by putting your name in the top in that blue cell. Make sure you put your name. Once you put your name, you're going to have 3 problems appear. Each problem is going to have a slightly different setup. You want to start by going through the problem and you want to identify the variables for the problem. And then you want to figure out which formula you should be using. You want to find the future value of the account for each problem. And then you're going to find the interest earned. And then if you invest monthly, you'll find the total invested throughout the time of that financial scenario. Okay, so let's get started with part 1. So part 1. We are going to compute the final value of an account into which you make a one-time deposit of $5,222 and leave the money for 6 years at an APR of 4.33% with simple interest. Compute the interest earned. Okay, so in this problem, you could have different numbers, but you should see the general same setup. We are making a one-time deposit into an account. We have a set number of years. We have a percentage, which is going to be our rate, and we are working with simple interest. When we look at our finance formula list, the first 2 formulas deal with simple interest. So we're looking at the first 2 formulas here. When you work with the simple interest formulas, the first formula tells you just the interest and the second formula tells you the future value. We want to start, if we go back to our Excel sheet, we're going to start by finding the future value of the account, and then we're going to find the interest earned, and they give us a specific formula to use for interest earned. So when we're talking about which formula to use for this first problem, we're looking for simple interest. We initially need to find the future value of the account. So if we're looking at our 2 simple interest formulas, we want the second one, which gives us the A value, which is the future value of the account. So we're looking at the second formula here, and I can go ahead and copy this, and I'll bring this over to my first tab so I can use it as a reference. I'm going to copy it in this white cell just so I can see it as I go. Okay, so we're working with simple interest. We need a P value, we need an R value, we need a T value. The P value is the principal amount. This is the money you deposit into the account. The R value is going to be your interest rate, and then the T value is the number of years. When you find the future value of the account, you want to make sure you start the formula with the equal sign. So after we put in all of our appropriate values into the green cells, make sure you use the numbers for your problem. You're going to find that future value of the account. You're going to start with the equal sign. Then you're going to do P times parenthesis 1 plus R times T. And we want to make sure we use cell references. So we'll type our equal sign. We'll click on the P value, type the star, open the parenthesis, type the 1 plus, then click on the R value, type the star, click on the T value, close the parenthesis. After the close the parenthesis, hit enter. This is the future value of the account. If it doesn't already format correctly, make sure you format this as currency with 2 decimal places. And a quick little double check, our money is increasing. We are making a deposit into an account. We're leaving it. We're earning interest on that money. So we want to see it grow. We started with 5,225 and it grew to 6,582. So it's a quick way to double check. We can see that our money is growing as we invest it. Okay, so let's figure out how much interest we earned. So interest earned equals future value minus the principal amount. Future value is the A. Future value and A are the same thing. A stands for the future value of the account. So what we're doing here is we're taking A minus P. So I'll start with my equal sign again, grab that value we just calculated, click on it, and then subtract the p-value. So type your minus and then click on the p-value from the original part of the problem and then hit enter. And that gives you the interest earned. You should get a positive number for interest. So that's another way to double check is that positive number for interest. This is the money you're earning. This is your free money in the savings account. Okay, so let's look at another example. So I'm going to leave you to do part 2 on your own. So I'm going to skip down to part 3 and we'll go ahead and look through part 3 and then you can try part 2 on your own. Okay, for part 3, we're going to compute the final value of an account into which you put $72.57 monthly for 6 years at a percentage of 4.33% compounded monthly. We want to also compute the interest earned. So we are going to figure out how much money we have in the account. So we need to compute the final value and then we need to compute the interest earned. If we go look at our gold cells, we're also going to compute the total investment. We need to find that total investment because that helps us find the interest earned. So first thing we're going to do is find the future value of the account. Then we'll figure out how much we paid into the account and then we'll figure out how much free interest we earned. All right, so which finance formula do we need? So going back to our problem, we want to look for our keywords. We are going to put in a monthly amount into an account. So we have $72.57 monthly going into an account. We have a percentage, we have compounded. So we have a monthly payment with compounded. We're putting money into a savings account. So this is going to be our future value of periodic payments formula. So if we go to our list of finance formulas, this is going to be the second to the last one. It's the A equals, because again, we're finding that future value, that A value. So we need to make sure the formula is A equals. And then that M in the formula represents the payment amount. So that's how you know you need this formula instead of the one with P, because you have a monthly payment amount instead of a one-time deposit. So let me grab this formula and I'll copy it into my document so we can follow it. So I'm going to copy it above because this is the formula we're using for part 3. Okay, so let's go ahead and let's find all of our variables. We need to find the monthly payment, the rate, which is a percentage, the N is the number of compoundings, T is number of years. So they told me in my problem, I make a $72.57 monthly payment. So that's what I'll put for my M value. My R is the percent increase. So that's 4.33%. Make sure you get that percent symbol in the cell. We are compounding monthly. So when you talk about compounding, you're talking about the number of times per year per 1 year. So for compounded monthly, monthly is 12 times a year. So our N value is 12. And then T is the number of years. We're doing this for 6 years. So our T is 6. All right, when you do the variables in the green cells, make sure you format the money cells as currency, get that dollar symbol in there. Make sure you get the percent symbol with the R values, and then N and T are numbers with 0 decimal places. All right, so let's find the future value of the account. So we're following this formula at the top here. We're going to again start with the equal sign. So start with the equal sign and then get my monthly payment. So do equal sign, click on my monthly payment amount, type my star, double open parenthesis, 1 plus, and then I need to do R divided by N. So I'll click on the R value, type my slash, click on the N value, close the parenthesis, and then we need our exponent, that's our caret key, that's above the 6. So we'll do our exponent, open parenthesis, then N times T. So click on the 12, type your star, click on the number of years you have. Close the parenthesis, minus 1, close the parenthesis, slash, open the parenthesis, type all that on your keyboard. And then after we get that open parenthesis, we need R divided by N. So go find the percentage, click on it, type your slash, find that N, which is our 12, click on it, close the parenthesis. Once you get to that last close parenthesis, then you can hit enter. And you're looking for the future value of your account. So you should get a number that represents putting monthly payment of $72.57 into an account for 6 years with interest on top of that. So that's why my number here is $5,954. That's why it's so much larger than my M value, because that M value is a monthly payment. We've made that monthly payment for 6 years and earned interest. All right, so there's the formula again if you need to see it again. Make sure you remember all the parentheses, all the symbols. If you get an error at the end of your formula, make sure you go back, double check those parentheses, double check the cell references. All right, so once we have the future value of the account, we also need to find the interest. Before we can find the interest, we need to figure out how much we invested. So right now, what we know is we know what we put in monthly, we know how long we put this in, we know the interest rate, we know how much we have in the account at the end of the 6 years. So we need to figure out how much did we actually pay into that account. So we're going to follow the formula M times N times T, the amount of payment we had times the number of compoundings times the number of years. So start with your equal sign, click on that monthly payment amount, type your star, click on the number of compoundings, type your star, click on the number of years, and then hit enter. All right, so in total, I invested $5,255. In the account, I have $5,954. So that extra money we have in the account is the interest we earned. So let's figure out how much interest we actually earned. So figure out the interest earned, we take A minus the total investment. So I need to subtract these two values, take the future value of the account minus the total investment. So start with my equal sign, click on that future value of the account, the A value, minus the total investments, and then hit enter. And again, you should get a positive amount. This is the interest earned, so this is your free money you earn into the account. So this last problem, what this last problem is saying is that if you paid $72.57 into an account monthly for 6 years with 4.33% interest, you would earn $729.34 in interest over that whole 6 years. You'd have almost $6,000 in the account, but out of all of that you earn in interest is only $729. All right, I hope this helps. Let me know if you have any questions.